All right, ladies and gentlemen, today we're going to be talking about defining functions with integrals. So this is something that, we solved problems without doing this before, but I just wanted to show you that it's possible. That if you're given a function f prime, sorry, that should be f prime right in there, and an initial condition, a comma f of a, so that's like, at a we know what the y value is, whether that's 0 or whatever. We can define f of x as f of x equals f of a plus the integral from a to x. Remember, this is the change, the total change or displacement in f of x from a to x. So here you're getting the change in values and you're having your start of values. And that doesn't matter whether your x value comes before a or your x value comes after a. This is a perfectly valid way of trying to evaluate and define a function if you're given a rate of change or given its kind of derivative, okay? So as an example, this is like a problem we've already solved before. And I'm just going to do this on I'm going to set up the problem and do it on a calculator and stuff so that you can see it. But essentially, we got water being pumped into a tank, and this is the rate of change in gallons per minute, where T is the number of minutes since it's been turned on. The tank, contained 800 gallons of water when it was started, so at 0, that's our initial condition here. And we want to know how much is in there after 20 minutes. So if we think of R of T, capital R of T, being equal to the total number of gallons in the tank at time t, then we can define it with this rate of change function as R of t is equal to 800, that's our initial starting value. And when did that happen? At 0, right? And we're going up to a time of t. Well, I should be using x here because I'm going to use t inside the integral. So after x minutes, and this is going to be 30 times 1 minus e to the negative 0.16 t dt. Okay, so you've got your initial condition here, that's your initial y value, that is your r of 0 from what they gave you, and our integral is from 0 and so on. Now if you plugged in 0 minutes, you would have an integral from 0 to 0, which would be 0, and you'd end up with just 800, right? So it makes sense with that initial condition that that's what you would get out. Of course, we want to know how much is going to be in there after 20 minutes, so we're looking for r of 20. That's going to be 800 plus the integral from 0 to 20 of 30 times 1 minus e to the negative 0.16 t dt. Okay, and so I think if you just go ahead and calculate that up, Math 9, 20, 30, 1 minus e to the 0.16, negative 0.16, x dx. I get 1,220.14 gallons. So check that out on your own. That's a nice way to do it. Now, some of the problems you're going to see are not going to be like this. Even though that's a nice formula to remember for defining a function if you're given its derivative. We're going to be given things like this, right? So g of x is the integral from 0 to x f of t dt. Now this bound doesn't have to be 0. Sometimes the bound might instead start over here at like 4, or maybe start at 2, or start at 3, or what have you. Okay? But regardless, of that lower bound, when we say g of 3, we're thinking of the integral going from 0 to 3. This here is actually the derivative of g of x. And we can do this just by doing our signed area problems from before, right? This is 1/2 base times height. That's 1/2 3 times 4, so this is 6. So g of 3 is 6. That is the value, if you plug in 0 here, right, g of 0, which I think is maybe in here somewhere, I don't know, it's not in here, but if I asked you what is g of 0, you'd end up with the integral from 0 to 0, so that would be 0. And so with this value being above the x-axis here, I can see that the areas are increasing. Like, this is a signed area function. Areas are going up, areas are going up, areas are increasing. Even from 3 to 4, this area is telling that the y values are going up by a factor of 2. Just find the area of that triangle. And then here, the y values are going up by an area of 1. This is an area of 2. This is an area of 1. Over here we have negative. Now our y values are decreasing, right? If we think of this as really g prime, all the stuff we did about increasing and decreasing and gridding and stuff, well, gridding the y values here, I can see the area is increasing my function's y values. Now my y values are decreasing. And you could actually grid the second derivative, which would be your slopes on here, you know, and so on. So what's g of 4 going to be? Well, you're starting out at 0, and then you're increasing by 6 and increasing by 2 more. We're at 8. All right. G of 9, that is accumulating all the area, signed area up to here. We're going to have some that's going to cancel out, right? So area of the semicircle is 1/2 pi r squared. Your radius is 2, so that's 4 pi. The whole semicircle would be 2 pi, so this is going to be negative pi here and negative pi on the other side. So if I did the, g of 9, the integral from 0 to 9, that is 8, 9, 10, 11, 12. I'm going to have like 12 minus pi is going to be my answer, right? G of 11 goes all the way there. It's going to be 12 minus 2 pi. Right? G prime of 3. Well, G prime of 3 is really just going to be f of 3. And what's f of 3? 4. G prime of 6, right here, what's the y value? Now look, I know this looks like a cusp, but remember, this is the derivative. We are looking at the derivative graph, so it's spitting out just the y value of 2. G prime of 9 is negative 2. Now, G double prime of 3 says, what's the slope at 3? Well, here, it does not exist because it is a cusp, because you have different slopes right and left, right? And we can do so. But we can analyze this function that is defined as an integral, based on this graph. Just remember, the graph actually is the derivative of g, just kind of written in weird notation. Instead of the derivative of g, it's g is the integral of f, therefore f is the integral or the derivative of g. Okay? So I hope this helps you with some of the problems. We'll be trying to work on some of this. There's a web work for it. I'd like you to try and practice. Stop by my office hours on Thursday, Friday. I will try and help you. Please don't wait until the end of the week in case you have questions, because I might not be able to get to it over the weekend, okay? So try and come by, and we'll take care of any questions, okay? Have a great week. Thanks.